This is my computer science NEA testing video where I will test my software to validate the correctness, robustness, and reliability of my Planetary simulation software. I will be having three testing types of data. Erroneous input testing, which verifies handling of invalid data which is supposed to crash the system. Typical input testing, a normal input should work correctly. So that is like changing a slider changes its value. A boundary input test, for example, if you have a star mass, which is supposed to range from 1 to 100 solar masses, the values 0, 1, 100, and 101 are boundary data. Let's start the test. Test number 1, opening the main menu. It's a typical test, and the app should just be launched. Expected outcome is start, load, create, and quit buttons are displayed and spaced evenly. Let's test that out. The app is launched, main menu opens, the start, load, create, and quit buttons are in fact spaced equally. So that will be a pass. The quit button is clicked. A typical test type, just click the quit button, all windows close and the app terminates. Here the quit button, close it, window does in fact close, and the app does terminate. So that is a pass. Pass. Test number 3. Start button is clicked with no system loaded. It's an erroneous test type. I should just click start. Message saying no file loaded. Load a file fast, and the program should not crash. Here, no file has been loaded, so clicking the start button will in fact show up and pop up this message, and the app does not crash, as you can see. So that is a pass. Number 4, load button is clicked. It's a typical test type, and I should just click load. A new window named Load System Window should open. Here, click Load button. Load System Window does in fact open, so that will be a pass. Number 5, try interacting with the main menu when Load System Window is open. Erroneous test type. Clicking on Quit or Create. That's what I should do when the Load System Window is open. The button should not work while the window is open, and an appropriate error sound should play. Here, click load. The window is open, and try to click any of these buttons. So start. And as you can hear, there is in fact a sound, a error sound playing, so that will be a pass. Number 6, create button is clicked. It's a typical test type, and click the create button. A new window named create system window should open. Here, create system window does in fact open, so that will be a pass. Number 7, try interacting with the main menu when create system window is open. Erroneous test type. Clicking on quit or create while this window is open. The button should not work while the window is open, and an appropriate error sound should play. Here, open the create window. Click start, load, or quit, and the sound does in fact play. So that will be another pass. Number 8, directory exists and contains .txt files. It's a typical test type, and the directory files with files test1.txt and solarsystem.txt. All file names are displayed on the canvas. So what this is saying is that all files here in files in this directory should show up on the canvas when I click the load button. So large system, solar_system, and test should be displayed. Click load. Large system, solar_system, and test are in fact displayed, so that is another pass. directory exists but has no .txt files. It's a boundary type, and the directory files, sorry about that, files with image.png. Canvas is empty except input box and load button. What this is saying is that instead of having files here, .txt files, I should have a image. So if I move these onto my desktop and then come here, take any of these images. If I copy, come here, open files, paste. Now run the program, load. Nothing is displayed and only the UI is here. So the text input box and the button is displayed. So that is another pass. Let's put the files back and delete this. The files back like so. And go on to our next test. So number 10, directory does not exist. Erroneous. No files folder. Rename the folder to anything else. An appropriate message should be displayed and the UI should still be drawn when clicking on the load button. So here, this file should be named to anything else. So let's name it to A star. I can't put a star. An A student. There we go. Beautiful name. Now let's run the program. Appropriate message is in fact displayed saying save directory is not found. And the UI is still drawn. So that is another pass. Change the name to files, back to files. And number 11, user inputs exact matching file name. It's a typical test type. User types in solar_system and clicks load. Message box containing system solar system loaded, and the window should close, returning back to the main menu. So if I run this, click load, and type in solar_system, like so, click load, solar_system loaded, window does close, and I'm back in the main menu. So that is another pass. Number 12, user inputs file name that doesn't exist. Erroneous. User types in Apple and presses load. An appropriate message box saying that no file has been found will be displayed, and the user will be prompted to enter a valid file name again. Here, Apple, load, unable to find file, try again, and that is a pass. User inputs a file name with extension. So for example, it's a boundary test type and the user types in solar_system.txt and presses load. An appropriate message saying something along the lines of invalid characters used will be displayed and the user will be prompted to enter a valid file name yet again. Load, we can copy and paste these by the way. So we paste it and put the extension .txt, click load, invalid characters used. So that is a pass. Number 14, user inputs empty string, erroneous test type. User presses load with nothing typed in. An appropriate message box saying that invalid characters used will be displayed, and the user will be prompted to enter a valid file name again. Load, nothing is in the text box. Click load system. Invalid characters used does in fact pop up, so that is a pass. Number 15, files with spaces in its name exist, like, for example, MySpace test.txt. It's a boundary test type. User types in MySpace test and presses load. File doesn't load as file does not load as invalid characters are used, and an error message should pop up. So here, go back to files and name this to MySpace test. If I can spell test, there we go. We're going to be trying to open up this file, run the program, load, and put MySpace test. Invalid characters used. This message does pop up and allows the user to try again, as you can see. So that will be another pass. Number 16. File name with invalid symbols entered. It's an erroneous test type. File, this file name over here. User types in this and presses load. Appropriate message saying invalid characters used should be displayed and prompt the user to try again. So we're going to have a test, a file name with this name. And we're going to be trying to type in that name, as you can see, this one. And it should not work. As you can see, it is in fact not work, and this message does pop up. So that is a pass. 17. Test for case-sensitive file names. It's a boundary test type. The file marssystem.txt, and the user types in marssystem. We can see the main changes. The file name has a capital M and S, whereas the user does not type in the capital M and S. Loads file and closes the window, so this should still work. So if I have here and I have a Mars system, like so, I run the program and enter Mars system like so without the capital letters. It is enabled to find the file because I spelt it wrong. Like so, if I copy and paste it, it does load the file, so that is a pass. And it does close the window as well. The 18th test. Load cancels without selecting a file name. It's an erroneous test type. Closing the window manually and use a breakpoint to check. The bool should be set to false and there should be no crash. So over here in load previous system.click, if I put in a breakpoint, run the program, click load, click F10, open it back up, and then manually closes the window by clicking the X button. As you can see, the result is in fact false, and that is a pass. F9. 19. File name input validation. Erroneous. Input star with these symbols. Appropriate message saying that it is a invalid file name, prompting the user to try again. So this is talking about our next window, our create window. If I try to create, let's say, a star with these symbols, it should not work. Please enter a valid file name. So that is a pass. File name already exists. It's a boundary test type. So the existing file will be test, and the user will type in test. Displays something like file name already taken, and allow the user to try again. So the Mars system, let's change that to test. Open the program. Click create, put in test. The file name test is already taken, and please choose a different name. And you can try again and again, and that is another pass. A valid file name continues to next step. It's a typical test type. We're entering a unique file name like system123 and clicking the submit button. The expected outcome is to move to create random system and update the UI. So here, if I have a unique file name, so unique, because you can see the UI does in fact update, and yeah, the file name was seen as correct, so that is a pass. Test number 22. User selects to create a random system. It's a typical test type. The user enters yes. A random system is created with 15 to 30 planets with all random attributes. Confirmation message tells the user the file name was created and how many planets were created. This closes the window and returns the main menu. So these should create truly random systems. We're going to test this out by creating 3 different files. So create random1. Yes, we want it to be random. File random1 created successfully in the files folder with 26 planets. Then you can create random2. Yes, we want a random. Random2 created successfully in the files folder with 18 planets. And one more, random3, submit, yes. File random3 created successfully in the files folder with 22 planets. To check that these are truly random, we can see random 1, 2, and 3 here. We're going to open random 1 and random 2, for example, and check them out side by side. We can clearly see that the star values are in fact random. The planet values are in fact random, and so on and so forth with the random number of planets as well. So that is a pass. Let me delete these as well. There we go. And that is a pass. User selects no or any other input where the user is asked to create a random system. That's a typical test type. Enter no and A, B, C, D, E should move to manual entry of planet count. Here we create, let's say, not random, submit. We do not want this. As you can see, it does go to the planet count, how many planets you want. It goes on to the next step. If you go back and we select no yet again, it goes back again. And if you put A, B, C, D, E, submit, it does in fact go here. So as long as you don't say yes, it will move on to the next step. So that is a pass. 24. Invalid number of planets entered. Erroneous. Enter -3, 11, and 2 exclamation marks. Appropriate error message, then prompting the user to enter a valid number of planets. So invalid number of planets entered. Let's see. Let's name it 1. Create another system. No, we do not want to do that. And here, let's test. We're told to test -3, 11, and 2 exclamation marks. So we're going to test -3. Appropriate error message is shown between 0 and 10. We can test 11. Again, it is between 0 and 10. And 2 exclamation marks. It is not a valid number of planets. So that is a pass. Test number 25. Valid number of planets entered. It's a typical test type. Enter 0, 5, and 10. These should all result in the moving on to the next state, which is star mass input. Here, we run it. Let's name this one 2, not a random system. And we're told to test 0, 5, and 10. So 0 does in fact go into the next stage. 5 does go into the next stage, and 10 also goes forward onto the next stage as well. So that is a pass. 26. Star mass is too high or low. It's a boundary test type. Enter 0, -1, 101, and 100.1. Appropriate error message should prompt the user to enter a valid star mass. So let's see. 3. We do not want a random. Enter something valid. And here, enter star mass in solar masses. So -1. Test that, does not work. 0. Appropriate error message saying please enter valid star mass in solar masses must be between 1 and 100 pops up. Test 101. That is a fail again, and 100.1 again does not work, and that is a pass. 27. Valid star mass. Typical. Enter a star mass of 150 and 100. These should all result in moving onto the next state, which is a star radius input. Here, we can test the number 1, goes on to the next step, which is the star radius. We can test 2. We can test 50 and 100 as well. 50 goes on to the next step, and 100 goes onto the next step as well, so that will be another pass. Test lower and upper bounds for temperature input. Boundary and entry 2999, 3000, 8001, and 8000. Only 3000 and 8000 should result in moving on to the next state and saving the star to the file. 2999 and 8001 should result in an error message prompting the user to try again. Enter the star's temperature between 3000 and 8000 Kelvin. Here, we are told to test 2999. That is a fail. Enter 3000. That is a pass. Go back, test 8000. This should pass as well. Yes, it does. And 8001, which should fail, which is correct. So that is another pass. 0 planets selected by user. When asked how many planets, the user should enter 0. This should cause the file to be saved. Appropriate messages should be displayed for the window to close and return to the main menu. So if you create let's say this one already exists, so number 2, create random system, no. We want to select 0 here. Then enter, doesn't matter what values, 1, 1, 5000. Now it should close the window and save the system. File 2 created successfully in the files folder. As you can see, number 2 is in fact here and is here as well, with star 1, 1, and 5000 as selected by the user, and that is a pass. Long planet name entered. It's an erroneous test type. I should enter very long planet name 123. Let me copy that. Error message telling the user that the name should be 15 characters or less, and that should be displayed. Here, entering very long planet name 123 should tell the user enter file name with 15 characters or less, as you can see. Leaving it null also tells the user to enter a valid file name, enter valid planet name, and that is a pass. Test the upper and lower bounds of planet distance. The boundary, enter -1, 0, 9, 1, 70, and 71. Only 1 and 70 should move on to the next state, which is a planet Y velocity, but the others should display an appropriate error message allowing the user to try again. Here, entering the distance, so we are told to test the values of here. We should test -1. That is in fact a fail. 0, a fail. 0.9, a fail. 1, which should be a pass, which is, as you can see. Number 70, which should be a pass, as you can see. And 71, which is not a pass, as you can see, which is a pass. Auto velocity generation. Typical. Select yes to auto velocity. When opening the file, the planet should have an almost perfect circular orbit. So let's see. create auto velocity. Let's name it that. Plus Z1, we want one planet. Let's give it 2 solar masses, 2 Earth radii, 6,000 Kelvin. Enter the name, just name it 1. Give it 4. Select yes. As you can see, this is the value for velocity. Enter the rest of the information. So give it 4, give it 2. Auto velocity, we can load that up. Use time warp to see that this is in fact a circular orbit. As you can see, which is a pass. Test number 33. Testing lower and upper bounds of planet mass. It's a boundary test type where I'm going to enter -1,000, 0, and a very large number. Only masses are in the range of 0 mass and to the limit +1, so basically from 0 to the limit +1, should be accepted. Anything else would result in a message to pop up. So let's test that out. So here you can see that the limit is 333 Earth masses. So we're going to test the number -1,000. That is an error. It has to be greater than 0. 0. Again, it has to be greater than 0. Just a big number. Please enter valid planet mass. So that will be a pass. Number 34. Planet radius out of bounds. It's a boundary test type. Enter 0, 100, 10, and 4. Only 4 should be seen as correct, or the others will result in an appropriate error message to be shown. Here, entering the Earth radius, we can enter in 0. That's between 1 and 6. 100. Again, same message. 10. And then 4, which you can see does in fact is seen as correct, and this does create the astas random name file, which is a pass. Number 35. All valid planet values. Typical valid name, distance, velocity, mass, and radius. Planets appended and saved to the file. So let's see. We're gonna enter all. So this is gonna be all valid. I can even put spaces actually. You cannot put spaces. Never mind. All valid. Create random system. I do not want to create a random system. I want one planet. 56. 1 and 7. You can see it has to be between 1 and 7. So let's give it 7. Give it 8,000. It will be called A, or just 1, sorry. A. 1 and 70. Let's give it 50. Give an automatic velocity, which you can see is 30 kilometers per second. Let's just give this one 8,651. Let's give it 6. And valid, all valid, created successfully in the files folder. We can see it here, all valid. You can open it up if you wish. You can also go to files and look at all valid, and it is correctly appended to the folder, which is a pass. Number 36, go back to a previous step. It's a typical test type. Click back button, returns to the previous state and input. What this means is, one second, let me go all the way to the back. So let's give it test. Let's give it 1. And here, from here, if I want to go back, I can go back all the way back. And when I click back, the values preserved before will be saved. So let's say if here I put hello, I mean this won't work. Let's put actual value number. Let's put 700. If I go to submit and I go back, 700 is saved. Then this automatic value is saved. The number 4 is saved. 4 is saved again because I inputted the same number. 3000 is saved. 4 is saved. 5 is saved. 1 is saved. Create a random system. Yes, no, this won't be saved. Enter file name. And then the back button is disabled. So going back works on every single step, which is a pass. Number 37, file creation message. It's a typical test type. After last planet is generated, make random system and manual system. Message alerting the user that the file has been saved, to files, and the window will close. So if I create a random, create a random system. Yes, no, let's create a random system. As you can see, the file creation message over here does in fact show up, and the number of planets. And if I want to make random 2, where I enter everything manually, so no, I want 0 planets, I want this 3000 Kelvin. As you can see, this message pops up again with the correct file name and that the file is saved, which is a pass. Test number 38. Load valid txt file with a valid star and planets. It's a typical test type. File solar system.txt will be loaded. Star and all planets created and simulation should start. So now this is testing the start button, where you obviously need to load a file first. You click load. We're going to load solar system. We're actually going to load it using the debug mode. Solar system, not debug, the diagnostic session. Solar system, load that. Start it. And as you can see, the star and all the planets are in fact loaded onto the screen. How many planets? 1, 2, 3, 4, 5, 6, 7, 8 planets are loaded. And you can see if we go to the solar system.txt file, we have 1, 2, 3, 4, 5, 6, 7, 8 planets, with the 1 star in the middle, which is the sun. As you can see, everything is loaded correctly and the simulation does start, which is a pass. Test number 39, load a file with missing fields. Erroneous. The file will be broken.txt with where a error message should be shown. So here we have test. Let's name it to broken. Broken. Broken has a star, a mass, and a radius, but has no temperature. So let's see what will happen to this file when we try to load it. Load. We're going to load broken. Error reading file. The correct message is in fact shown, which is a pass. With a correct file, I'm going to hold down the P key for 2 seconds and then do the same with the escape key. I'm going to hold P and then hold escape, as I just said. It's a typical test type. The pause overlay appears and the simulation should pause. So here, I'm going to load in solar system. Start it. Let's run it in diagnostics mode. And solar system. So here, I should hold down the P key. Let's hold the P key first for 2 seconds. As you can see, that does in fact pause the simulation and open the pause overlay. Now let's try the same thing but with an escape key. And as you can see, the pause overlay does in fact open yet again, which is a pass. Test number 41. Open the pause overlay and test that the simulation unpauses when clicking continue. It's a typical test type. I should click the continue button, and what I should see is that the simulation resumes and the timers start again. So let's run it in the diagnostics mode. Open solar system, start it. We can go to the pause button. As you can see, everything pauses, and you can see the pause overlay with the continue main menu buttons. If I click continue, what should happen is all of the simulation resumes. And as you can see, it does, and you can see this better if I increase time warp. If I click pause, everything stops. Click continue, everything resumes, which is a pass. Test number 42. Open the pause overlay and test that the simulation closes when clicking on the main menu button. It's a typical test type. I should click the main menu button. Simulation window closes and the main menu opens up. Here, open the pause button, the pause overlay, sorry, and clicking the main menu should close this window, which you're going to be able to see down here as well, and open the main menu window. And as you can see, the main menu window opens, as you can see, and the main window closes, which is a pass. Test number 43, adjust temperature slider. It's a typical test type. Set to 572 Kelvin, which is a sun temperature or a temperature approximated to around that value. The color of the star should dynamically change as the value of the slider changes. The color of the star should be green. The reason that it should be green is because the peak wavelength of the sun is in fact a green color. So here the temperature is at 7,000, and let's open it in debug mode. And setting a temperature of about 5,700. As you can see, this is in fact a green color, which is a pass. Toggle show max wavelength checkbox to off. It's a typical test type. I should uncheck the checkbox. Star changes to a gradient fill. Changing the star temperature won't do anything to the color of the star, as we have just seen in the previous test. So here, I should uncheck this show max wavelength for the star checkbox. As you can see, this does give it a gradient fill, a more starish feel, I would say. And changing the temperature slider doesn't do anything to the star, which is a pass. Number 45, test drop-down menu and select Earth. It's a typical test type. Select planet. I should select the planet in the drop-down menu. And correct planet data shown at the bottom of the screen while being updated during runtime. Load. Solar system, let's run it this mode again. Solar system, start, and upgrade the time warp just a little bit. As you can see, you can select Earth here. Mass is displayed in kilograms. Velocity does dynamically change. Excuse me. Distance dynamically changes as well. Orbital period stays the same because the orbital period is basically the same. The change is negligible due to the forces of the other planets, and the force on the planet also changes dynamically. As you can see, the orbital period is 1 year, which is correct. The distance from the star is 1 astronomical unit or thereabouts, which is correct. And the velocity is around 30 kilometers per second, which is correct, which is a pass. Number 46. Sort the drop-down menu by mass. It's a typical test type. I should select the sort or how I want to sort it. And the planet drop-down rearranged in descending order in mass. This makes use of my merge sort algorithm. So load solar system. And we can see that currently there is no sort, but if I do sort by mass, then you can see the stars are biggest, but the star is always the first. Then it's Jupiter, highest mass, Saturn, second highest mass, Neptune, third highest mass, Uranus, I forgot which one this was, first, second, third, fourth highest mass, Earth is the fifth highest mass, Venus is the sixth highest mass, Mars is the seventh highest mass, and Mercury is the eighth highest mass, which, as you can see, it's all correct and merged, sorted correctly, which is a pass. Test number 47. Sort the drop-down menu by distance. It's a typical test type. I should select the sort again. Planet drop-down rearrange in ascending order in distance. So now the distance should be getting larger and larger the more I go down the drop-down menu. Load solar system. Here, I'll select sort by distance, where the star is fast, as I just said, is always fast, or you can select nothing as well and it shows nothing selected. Mercury is the closest one to the sun. Venus, Earth, Mars, Jupiter, Saturn, Uranus, and then finally Neptune, which is about 30 astronomical units away, which is all the way over here on the screen, that little blue dot, which is a pass. Number 48. Adjust the time warp select to 550x. It's a boundary test type. I should drag it to the max value. Simulation runs at the fastest speed. Here, let's run it. Load solar system. Or you can try this with any other system, but this one is a good reference point. And as I turn up this, as you can see, it goes higher and higher. As you can see, this is the maximum speed. I could turn it down so they go slower and zoom out even more a little bit. Something like that. You can see they stop here and they go really fast here, like so, which is a pass. Test number 49. Check that closer planets have lower time multiplier values. It's a typical test type. I'm going to be using debug.writeLine and update position method. We should see that planets like Mercury are capped at a time multiplier of 40. So in this if statement, we're going to set the time multiplier of the body to 40, and we're going to print which bodies are being affected by this if statement. So if we see Mercury, and most probably the Sun, of course, because it's close. So the Sun and Mercury should be displayed in the debug. Open up the solar system, like so, and make the time warp go big. And we can look up Mercury as well because it is very close. Then it's Venus, which is actually close as well. So Venus, depending on where it is in the orbit, could actually be there as well. Because the if statement states that if the distance is less than 0.9, so Venus probably shouldn't be in there. Let's see. Quit, and we see that Mercury, Venus, star, Mercury, Venus. So Venus is affected by this as well, which is a pass. So the closest planets, as we saw, which is Mercury, then Venus, are being affected by this cap, and then planets beyond that, like let's say Earth in this case, and then Jupiter in this case, and so on and so forth, are being affected by different caps to ensure stability. Test number 50. Adjust zoom slider to minimum and maximum values. This is a typical test type where I'm going to drag the slider. We should see that when the value of the slider is at a maximum value, it is fully zoomed in. And at a minimum value, it is fully zoomed out. So let's test that out with our beautiful solar system. Let's open it. We can see that when it's at a minimum, fully zoomed out, when it's at a maximum, fully zoomed in, which is a pass. Uses the arrow keys to adjust the zoom slider value. It's a typical test type. Press the right arrow key from the minimum value to the max. We should see that the slider moves faster the more zoomed in you are. Or we can reverse that saying and say that it moves slower the smaller the value. So let's test that out. Because we are going from left to right, so if we start the simulation, and because we are starting from left, from this is time warp, sorry, for zoom, we're staying fully zoomed out, so it should, the slider, if we look at the slider over here, we should see that it slowly is creeping towards this side. But once, let's say, it gets about around here, or even here, it's going to start moving quicker and quicker the farther along it is. So let's test that out. As you can see, it's going quite slow. It's starting to speed up even more, and more, and more, and more, and so on. However, if you look back at the video, we saw that while this was moving at a different rate, the zoom in and zoom out looks perfectly linear. It's an inverse relationship, and therefore it is a pass, because the more zoomed in you are, the faster it moves, which is a pass. Number 52. Check then uncheck the hide trails checkbox. It's a typical test type. Check then uncheck the box, as I just said. All orbits and trails should disappear when checked and reappear when unchecked. So let's test that out with our solar system. If we give it a bit of a larger time warp value and let the trails build up a little bit, let Saturn go all the way around. There we go. If we if we check the high trails, all the trails are in fact gone, as you can see. If I uncheck it, the trails come back. As you can see, it is a toggleable checkbox, which doesn't delete them, it just makes them disappear, which is a pass. Test number 53. Set star temperature to 3000. It's a boundary test type. Use a slider to select a temperature of 3000 Kelvin. It should return the minimum visible value. So we should see a deep red. Even though a temperature of 3000 Kelvin, is in fact below the visible spectrum of light, it should still handle those extreme values and return a deeper red. So right now it's at 7000. If we go down, we see that it's red, deep red, and then here it doesn't change because it's in the non-visible spectrum of light. But once it does get to the spectrum, visible spectrum, as you can see that the color does change, which is a pass. Test number 54. Test a system with 70 planets. It's a boundary test type. I should have a large txt file loaded, all planets loaded with no crash of the program. So here I have a large system.txt file with about 70 planets over here. And I'm going to load that and see how my program fares with such large systems. Remember that the calculations have a time complexity of big O of n squared. So there are a decent amount of calculations with very large numbers, and I just loaded the wrong system. Let me redo that. Okay. Here you go. Let me redo that. Load large system. And here, as we zoom out, we see that there are a lot of planets. Probably even off the screen, to be honest, but because the program isn't made to fare with this many planets, that is fine. You can see all the planets here. All the planets like so over here. We can turn the time up, and we're going to see the variation and deviation in some of these velocities as well. Because they are going to have circular orbits, the further ones have a bigger deviation, causing them to either go further closer to the sun. So let's see how it fares with such big systems. As you can see, these here, it's a very cool phenomenon which is called a slingshot. Each planet, the smaller planets are getting a gravity assist of the bigger planets, which launch them into space. We can hide the trails, which looks kind of cool in my opinion. We can turn the time up, put them back on. We can, so as you can see, it is quite laggy, but there are a lot of planets over here. We can hide the trails, show planetary data, that works. Show lambda max for the star, so let's hide the trails. Show lambda max, this doesn't change anything. We can toggle it, and this does change the color of the star. We can zoom out. We can sort by mass. So we can see that the highest mass object in this system is actually of 4.491 times 10 to the 27 kilograms, so around the mass of Jupiter. We can select by distance. So the closest the closest planet is number 2. So if I hide the trails and make this slower, this planet right here has a name of 2. It's at distance 1.72 astronomical units, and we can test this by going down and seeing that 6 is a bigger value, Z is a bigger value, and so on and so forth. And then we can go to the farthest one, which is extremely far away. We can do the same thing with mass. So H, biggest mass, we already checked that out, and A, smallest mass, and that is a pass. It works fine, a little bit of lag. However, with this many UI objects, large number of planets, and large just numbers in general, I think it has done very well, which is a pass. And on to our final test is to toggle show planetary data. It's a typical test, and I'm going to uncheck the checkbox. The planet data should disappear when it is unchecked. So let's see. We're going to test our solar system. We can check nothing. We can toggle this, it is hidden. We can select Mercury, select this, it is hidden, and so on and so forth with all these planets, which is a pass. And on to our final test, number 56. It will be to run through the whole program. It is a typical test type, meaning that we're going to create our own random or non-random system. In my case, I'm going to make a random system, load it using the load system window, and simulate it. Everything should still be functional and work as intended. So let's check this out. We're going to start it. We're going to create our own system. This is going to be our my system. I can use an underscore my system. Submit. Create random system. Yes, please. As you can see, the messages still pop up. 19 planets have been generated. We can copy and paste these as our objectives state that we should. We can load it perfectly fine. We can start the simulation, but before that, we can check that starting the simulation with no loaded file will in fact lead to this pop-up. We can load my system, start it. We can check that the temperature slider works. It goes from 3000 Kelvin to 8000 Kelvin. When the show maximum wavelength for start is checked, then that means that the color can change based on the temperature, as you can see. We can uncheck it. This makes the temperature slider not work for the current duration, but when we check it back, the color changes, as you can see. So the temperature slider works. The zoom slider works perfectly fine. We can also hold our key. Let's do it from the opposite end this time. And hold our key, and we can see that it goes super quickly at the start. Then it goes slower and slower and slower and slower. This maintains a linear zoom out, as you can see. It doesn't go quicker and then slower when zooming out when using the arrow keys. There we go, fully zoomed out. You can see the temperature, sorry, the time up slider works perfectly fine, like so, with all the 19 planets. We can toggle the trails. We can select different. You can select different planets and make sure that we can see all the information, which updates in real time. We can sort it by mass, where S is the biggest planet in mass, is the most massive planet, and D is the least massive planet. We can sort by distance, where where D is the closest one. So this planet over here is the closest one to the star. So this one's D, and the farthest away one is L. We can hold the escape button for 2 seconds, opens the pause overlay. Hold the P button for 2 seconds, it opens the pause overlay yet again. We can toggle this, toggle the data, toggle the star, toggle the trails, and then we can click the pause button and then return to the main menu if we so wish. After this, we can quit and terminate the program, which is a pass. As you can see, everything was a pass and the program works as intended.